Okay, let's talk chemistry. It's been a while. Okay, the last time we did anything chemistry related was before Thanksgiving. Okay, and by the way, just in case someone's watching this not from Canada, real Thanksgiving is in October. Because that's the thing. Okay, all right, so we have the first thing that we talked about, okay, in chemistry was the history of the atom. There's very little on the final exam about the history of the atom. There's a couple of multiple choice questions about structure of the atom, okay, you know, the particles, the protons, neutrons, electrons, the nucleus, okay, the electron cloud, okay, things like that, okay. Certainly that you would need to know, but like not huge amounts of marks, okay. We're talking 1 or 2 marks on the entire test, which is out of like 130. Okay, so it's not a big part of the final exam. Go over the notes once or twice and you'll be good. Okay. Something that is important though is this. Being able to name and write the proper formulas for compounds. That is your most important fundamental skill for chemistry. Because if you can't do that, it's going to be very difficult for you to write reactions, get them balanced, get them predicted, okay? All of those important things that are big skill marks on the final. Right, so definitely review naming compounds. Ionic compounds have different rules than molecular compounds. Okay? Review the drop and swap. When do I use brackets? Okay? What are polyatomic ions and how do they work? Okay? It probably won't take you long. Just look at the worksheets. Remember, the keys are posted in Google Classroom. Just do a couple to make sure you still know how to do it. If you're getting them all right, you probably don't need to spend any more time on it. Okay? This is kind of a big thing for studying for a final, is making the best use of your time. Right? If you know how to do something, you don't need to study it anymore. You need to move on to the things you're not as good at. That's not as much fun. So we have a tendency to focus on, oh, I'm good at this and it feels good to study it because I get it right. Yeah, but that doesn't help you with the stuff you don't know. Okay? So if you've done a few naming things, you're getting them all right, you're good. Move on to reactions or the mole equation or something like that. Okay? All right, writing formulae. So we just talked about that as well. Okay, that's going to be an important one. Okay, and then lesson 12. Okay, lesson 12 is where we learned about the 5 reaction types and how to write and balance them. Okay, and that is a super important skill, okay, for us to be able to demonstrate on the final. Okay, so in terms of like marks for chemistry, okay, so the whole final exam is out of 137 marks. Okay, I know that seems like a lot, but I was like stupid generous with the marks in the written response. Like some questions that should really be out of 3 or out of 5. Like, so, you know, I've given you a mark for, you know, spelling your name correctly kind of stuff. Like, okay, I'm being pretty generous. That's why it's out of so many marks. Okay, but to give you an idea, in the written response, sorry, in the multiple choice, there are 16 chemistry questions out of 50. Okay, there's 50 multiple choice. Only 16 of them are from chemistry. So that's less than a quarter. Okay? Sorry. No, it's not. It's slightly more than a quarter. I did the math wrong. Okay. All right, and then in the written response, okay, we are looking at 11, 19, 27. Okay. So there's 27 marks in the written on chemistry. Okay, so that's 43 of 137 marks on chemistry. And I'm going to ask you to do exactly the same things I asked you to do on your unit exam, just not as many times. Okay, so on your unit exam, the first question was 7 reactions that were fill-in-the-blank balancing. On the final, it's 3 reactions. Fill-in-the-blank balancing. Okay. On your unit exam, there were 4 reactions that had to be predicted, written out, and balanced. On the final exam, there are 2. Okay. And on your unit exam, there were 4 mole equation questions. On the final exam, there are 2. Okay, I'm asking you exactly the same things on the final as I asked you on the unit exam. Okay. All right, so make sure you can do the reactions, the predicting, the balancing, okay, and then the mole equation. Okay, being able to use n equals little m over big M, okay, Avogadro's number. Remember, you're getting a fresh periodic table, okay, on your final exam. Okay, so if you've lost yours, no big deal. You're getting a brand new one of these, okay, complete with all the numbers and constants and everything else on the back. Okay, so you don't have to memorize any of the stuff that's on here, including Avogadro's number. Okay, that'll all be on the final. Okay, other important things within that unit, not for the written, but for the multiple choice. Lesson 4, properties of compounds. We did a lab on that. Okay, you had to identify the unknowns based on their physical properties, like if they're observable properties, so their color, their texture, okay, stuff like that. Solubility, aqueous conductivity, and pH. Okay, there could definitely be some multiple choice questions on that kind of thing. Like you have a pink crystalline solid that is highly soluble in water and conducts electricity very well in solution with a pH of 6. Okay, this compound would be A, hydrogen chloride, B, diphosphorus pentaoxide, C, cobalt 2 chloride, or D, nickel 2 bromide. Which would it be? C, cobalt, because cobalt containing compounds are red or pink. Okay. All right, so things like that. So lesson 4, definitely go over that. Okay, if you're reading over your notes, that's the lesson I would probably read over the most. Okay. Okay, solubility in the polar nature of water was lesson 8. Right? On your unit exam, you actually had a written response question where you had to explain to me what it meant to be a polar molecule, okay, and things like that. There's no written stuff on the polar nature of water, except maybe in transport in plants in the biology part, okay, but not in chemistry. But there are a couple of multiple choice questions about, terminology, solute, precipitate, solvents, okay, things like that, okay, as well as, cohesion, adhesion, those behaviors of hydrogen bonds that polar molecules can exhibit. Okay, those could be in the multiple choice. Okay, so again, like lesson 4, probably the most important one to read over. Lesson 8 would be the next most important one for just reading over your notes. Okay, so read them a few times and you'll be okay. Okay, so like I said, I was telling you this, I got ahead of myself. So in the written response, balance, predict and balance a reaction, and mole calculations. Okay. Okay, so naming rules, just as a quick review here. Okay, if we are talking about ionic versus molecular, there are different rules. See if you can write the names of these two compounds. See how much we remember. Okay, give you a minute, and then we'll go over it. So, this one's an ionic compound because it contains a metal and a nonmetal. Rules for naming ionic compounds. Write the name of the metal, magnesium, and then the name of the nonmetal, chloride, ending in ide, obviously not in ene. Okay, so that's it. That's all there is to do with that. Magnesium chloride. Naming simple binary ionic compounds is just that. Simple. Okay. For molecular, I still write the names, but what do I put in the names that I would never put in the name of an ionic compound?
Dinitrogen trioxide.
Right, I put in the prefixes. Okay, di, tri, tetra, okay, all of those. Okay, so this would be dinitrogen trioxide.
Are those prefixes going to be on the periodic table?
Nope,
Okay.
they are not. Those ones you'll need to know, and probably not past like 5. Okay, try that one. It might involve something the first one didn't. Okay, what's different about this one? It needs a Roman numeral because iron is multivalent. That means it has more than one possible charge, which I can see if I look at my periodic table. Okay, it can be a 3+ or a 2+. All right, so when I write this, I'm going to start out just like I did with the first one. I'm just going to write iron oxide. Okay, but since I've looked at my periodic table and I see that iron can be a 2 or a 3, I've got to figure out which one it is. So for that, I look to the nonmetal, okay, because the nonmetal is only ever going to have one possible charge. Oxygen is always a -2. Okay, there are 3 oxygens, each one of them with a -2 charge. That gives me a total of 6 negative charges. A proper compound must have an overall charge of 0. That means I have to get 6 positive charges from the 2 irons that I have. 6 divided by 2 tells me that each iron has a +3 charge. That means this is iron, Roman numeral 3, oxide. Okay? Ringing a bell? You have to do a little bit of math there. Okay? Nothing difficult. Okay? Try that one. It might have something the other 2 didn't have. Okay, so for this one, still an ionic compound, okay? I write the name of the metal first, just like I did with all the others. So Na is sodium. And then I can see that I don't just have one element, I have 2. Okay, that means I have a polyatomic ion in this ionic compound. So I have to go to that chart at the top of my periodic table, okay, and find out where CO3 is. Okay, so CO3 is right here. Okay, it's a -2 charge and it's called carbonate. Okay, I don't change the name of polyatomic ions. So this is sodium carbonate. Done. Okay, that's all I have to do for writing the name. Okay, questions on that one? Now, let's see if we can go the other way. I want to go from name to formula. All right, so try the 2 that are on the board there right now and see how you do with those. Okay, so if I'm going to write the formula for an ionic compound, and this first one is, okay, I write the formula and the charge for each part. Nitrogen is a -3. Okay, what do I do with those numbers? Drop and swap. So I drop the 3, swap it over here, drop the 1, swap it over there. We don't write 1s. Done. Li3N. Okay. for molecular compounds, because this one is a molecular compound, I just go by the prefixes. Tri means 3, P3. Tetra means 4, PR4. Okay, don't have to worry about dropping and swapping or balancing charges or anything like that for a molecular compound. Okay, just for the sake of expediency, I'm just going to walk through a couple of these. All right, so for magnesium oxide, okay, ionic or molecular?
Ionic.
It's ionic. Magnesium is a metal, okay, and it has a 2+ charge. Oxygen is a 2-. If I drop and swap these, what do I get? Right, it's already balanced, okay? It's a +2 and a -2. It already adds up to 0. MgO is my formula. If I drop and swap and I can reduce the numbers, I do. Mg2O2 can be reduced to MgO. Okay? If I had like Mg2O4, I would reduce that down to MgO2. Everyone follow me there? Okay? If you can reduce, you do. In an ionic compound, not in a molecular compound. Okay, try those two. Okay, so for copper 2 sulfates, okay, it's an ionic compound. Okay, got copper. The Roman numeral tells me this is not the 1+, but the 2+ copper. Okay, and it is with sulfate, which is a polyatomic ion, SO4, that has a -2 charge. Okay, because one's a +2 and the other's a -2, do I need to do any dropping and swapping? I don't. Those already add up to 0, so that compound is good the way I have it written. Okay. Now, for the second one, that's not the case. Okay. I have nickel, and the Roman numeral tells me it's the 2+ charge nickel, and it's with hydroxide, which is a polyatomic ion, OH, with a -1 charge. Okay. Now, when I drop and swap, the 1 will go over here with the nickel, and the 2 goes here. But what do I need to do before I put the 2 here? Put OH in brackets, because if I leave it like this, it's 1 nickel, 1 oxygen, and 2 hydrogens. That is not nickel 2 hydroxide. This is 1 nickel and 2 hydroxides. Okay? That's when we use the brackets. Okay? When we have a polyatomic ion with a number outside of it, okay, or a number beside it that needs to be enclosed in brackets. Okay? If I needed to put a number beside SO4, would I take out the 4? No, I would do this. I would enclose and then put the other number here. Okay, that making sense? Okay, if a polyatomic ion comes with a number, don't change that number. Okay, that number stays with it. We put other numbers around outside the brackets. Okay, what kind of reaction is that? It's a synthesis reaction. Okay, 2 elements are combining to form a compound. Is it balanced? It's not. Okay, so the balancing rules are, I look for the biggest number. Biggest number is 2. Okay, there's 2 chlorines on this side. How many are there over here? Well, 1. Okay, so how do I make that work? Just do this? Why can't I do that?
No, because then it would be sodium chloride.
Right, then it won't be sodium chloride and it doesn't work in terms of balancing. Okay? So, I put a 2 here instead. Okay, now there are 2 sodium chlorides. That gives me my 2 chlorines, but putting that 2 there also gives me 2 sodium. So I'm going to go back over here, put a 2 there. Is it balanced now? Yes, it is. Okay. All right, what kind of reaction is that? combustion reaction. Okay? Combustion reactions always have the same products. Carbon dioxide and water. Right? Is it balanced? Are there special balancing rules?
Yes.
Yes. Okay, combustion reactions have their own balancing rules. Okay, balance alphabetically and the rule of 2. Okay, so if there's an even number of carbons, I start with a 2. That's the rule of 2. Okay, I have to apply the rule of 2 here, okay, because there are 2 carbons, that's an even number. All right, now I balance alphabetically. How many carbons are there? 4. Okay, so I need to put a 4 here. All right, how many hydrogens are there? 12. Now there are 12 over here. Now I can balance the oxygens. Okay, there are 4 times 2 is 8 oxygens right here, plus another 6 for a total of 18. Okay, no, sorry, 8 and 6 is 14, not 18. More coffee is necessary. Okay, 8 plus 6 is 14. So what needs to go in front of this? Right, 7. Okay, is that ringing a bell? Other than Coderre's coffee-free math? Okay, all right. Okay, let's actually do the prediction on this one. Okay, what kind of reaction are we looking at here? It's a double replacement reaction. Okay, in a double replacement reaction, what happens? What do I do with the metals? I switch them. Okay, they switch partners. So, on this side, sodium was with oxygen. On that side, sodium will be with nitrogen. Okay, and that means that magnesium will be with oxygen. All right, so I've determined who's with who. What do I have to do with the 2 compounds I just made? Well, okay, like balance the reaction or the compounds? The compounds. What have I not done to these 2 ionic compounds? I haven't dropped and swapped yet. Okay, I just put them together. They're definitely not dropped and swapped. Sodium's a +1, nitrogen's a -3, so this will be Na3N. Okay, this is a +2, this is a -2, so that compound is okay the way I have it written. This is why being able to drop and swap right formulas is so important. Okay, all right, so now I'm looking at this. Okay, I've got to now do what? I've got to balance the whole reaction. Okay, so biggest number is 3, and it's on 2 different things. It's on sodium and magnesium. Which one should I balance first? The one with the greatest charge, because it's going to have a bigger effect on everything else. That means I'm balancing magnesium first. It's a +2, sodium is a +1. All right, so there are 3 magnesiums over here, so I'm going to go over here and put a 3 there. Okay, when I do that, that gives me 3 oxygens. So I got to come back over here and put what here? A 3. Okay, when I do that, it gives me how many sodium? 6. Okay, what needs to go here? All right, when I do that, does that make my nitrogen work? Yes. Had I started with sodium, it wouldn't have worked out that way and I'd have had to start over. Okay? All right. Everybody okay with that? Okay, is it ringing a bell? See how well we remember the mole equation. That's the easiest type of mole equation question. All right, let's have a look at this, see what we remember in the last 5 minutes here. Okay, so we're looking for how many moles. That means we're looking for N. Okay, they tell us it's sodium sulfide, which will help us get the molar mass. Okay, sodium sulfide. this is a -2, this is a +1. So we're looking at Na2S. So that'll be 22.99 times 2 plus 32.07. Yeah. Okay. Okay, what do we get for a molar mass there while my calculator's firing up?
78.05.
78.05? All right, so, and that's grams per mole. Okay, so I have, the last thing I have is that the mass is 250 grams. All right, so if I'm calculating the number of moles, it's mass divided by molar mass, 250 divided by 78.05. And it didn't fire up anyway. Okay, what do we get there? You're like close to 3? 2.8? What is it? What is it, 3.2? Okay. 50 divided by 78.05. Exactly, 3.20 moles. Okay, ringing a bell? All right. A skill worth practicing? 8 marks. Okay, there's 2 of those. All right. So, guys, don't back up. We still got time here. Tomorrow, here's the plan. Okay. Tomorrow, I'm going to quickly go over biology. Okay, super quickly. And then I will take questions from you. I'll probably have a few questions if you guys don't have many. Okay, but I want to answer what's pressing for you. Okay, so come with questions tomorrow so I can answer your questions about the final. Okay, Mr. Coderre, can we go over, more mole equation or more predicting reactions, or can we go over a work energy theorem question or whatever? Okay, you come with questions. I'll do as much as we can in class. Okay, as many questions as you have. If you don't have a lot of questions, then I'll have some ready to go for us to go over that I think are important. But it's better if I get what you think is important. Okay, done first. All right, so we'll get the most out of tomorrow. You guys come with lots of questions. Oh, also, yesterday I posted in Google Classroom the final exam review. Okay, so it's all in here. Okay, I also posted old videos from previous semesters. Okay, of the review thing if you wanted to look at those. Okay, but this is the review questions right here. This PDF document. So there's a bunch of stuff in there you can do. The answers are in bold, so you can check and see if you did it right. Okay, for basically all of them. Right, so definitely worth having a look at. I don't have answers, I think, for some of those ones for biology because you just have to look them up in your notes. Okay, there's physics ones with the answers in there. Okay, there's global systems with some answers in there. Right, so make sure you're having a look at those. Okay, and I mean that's not everything, obviously, that you could do, but it's a bit of a guide at least. Okay, and then past the bottom of that, there's also kind of an outline here, key concepts and skills that you have to be able to demonstrate, okay, for each of the units. So, okay, have a look at it, it's what's there. If you want, obviously you can watch the review things from previous semesters. In each one of those, the reason I post those is the class asked tons of questions, and so I just went over basically everything they asked, plus some that I made up. Okay, so if you were looking for something like that, it's available to you there. Just click on them and it'll take you to YouTube to watch. Okay, remember that my help times during exam week, okay, are Friday from 11 to noon, and the 24th, which is Tuesday, okay, from 11 to 1. All right, so you can come in and see me during those times and ask some questions, look over your old tests or whatever it is you want to do in terms of prep. And reminder that your final exam is January 25th, 9 a.m. down the math wing, St. Vincent de Paul. Okay, see you guys tomorrow.